In this video, we're going to cover the confidence interval estimate for the proportion. And this is very similar to the confidence interval estimate for the population mean. So we're going to do something very similar here. All right, so just to remind ourselves, what is the confidence interval estimate for the population mean when the standard deviation is known? Well, that is x bar plus or minus z times sigma over the square root of n, where x bar is the sample mean, sigma is our standard deviation of the population, and sigma over root n is the standard error of the mean. So, what is the confidence interval estimate for the population proportion? Well, that is a very similar formula here, where we have p plus or minus z times the square root of p times 1 minus p over n. But what was p? P is equal to x over n is the sample proportion. And the square root of p times 1 minus p over n is the standard error of the sample proportion. Previously, the standard error of the proportion was just pi, where pi was the proportion of the population. And so it was pi times 1 minus pi over n. Here we change that to be p times 1 minus p over n, only because we know the sample proportion p, but we won't be able to know what the population proportion is. In fact, that's what we're trying to estimate. So we need to use our sample proportion in the calculation for the standard error of the sample proportion. Okay. Well, one quick note. To use this equation, we need x and n minus x to be greater than 5. That allows this formula up here to be a good estimate. All right, so we just want to do a quick example with all of this information. So let's do that. So let's suppose we have an example here that in a survey of 1,003 adults, 381 complained to a restaurant of disruptive neighbors. So let's construct a 90% confidence interval for an estimate of the population proportion who would complain of noisy neighbors at this particular restaurant. So how do we do that? Again, let's draw a picture. We don't need to draw this picture every time, but I want to do that to make sure y'all understand where the z-score is coming from that we're going to use. So if we want a 90% confidence interval, that means we have 45% below and 45% above the mean here. Right, this whole region here is 90%. If we have 90% here, that means we have 10 on the outside. So we have 5 below and 5 above. So if we have 5% above, that means this mark right here is 95%, right? We have 95% cumulative area below this line here. So the z-score that corresponds to this point right here is z equal to 1.645. Now, how would you find that? Go to your cumulative percentages chart and find out what z-score corresponds to 95%. And we find that that is approximately z is equal to 1.645. So that's the z-score we want to use for this problem. So then we just plug it into our formula. Remember, our formula was p plus or minus z times the square root of p times 1 minus p all over n. Well, where p is equal to 381 over 1,003, which is approximately 0.3799. So we plug in that for p everywhere. Z is approximately 1.645. That's what we just calculated above. N is 1003. That was our sample size. So our interval goes from Z minus, can you see that? Z minus, P minus Z times the square root of P times 1 minus P, all over N, is less than pi, where pi is our population proportion, which is less than P plus Z times the square root of P times 1 minus P all over N. So we just plug in these values in the appropriate spots here. So this is 0.3799 minus 1.645 times the square root of 0.3799 times 1 minus 0.3799, all divided by 1003. And this is less than our population proportion. And then 0.3799 plus 1.645 times the square root of 0.3799 times 1 minus that, all over 1003. And this gives us our 90% confidence interval. As in, 90% of these intervals that we'll create will contain our population mean. All right. And that is it for this video.